question. That is the eighth one. We are given a Poisson process which is defined with the following properties. So now the number t n t1 comma t2. Okay, so we're given the interval is t1 to t2. Okay, of length t is equal to t2 minus t1. Okay, and we are given parameters as lambda into t. We are also given the formula. Now basically we are also given that if the intervals t1 comma t2 and t3 comma to are non-overlapping, the random variables are independent, which is given over here. These are the things that is given to us. Okay, so moving on to what we are trying to solve over here is we need to find what is e of x of t and what is r t comma t1 comma t2. E of x of t. So we are given that r. Okay, this is basically the Poisson process where I kept, instead of using the letter k, I use letter m in this case. Okay, so now what we're trying to do is we're trying to solve the equation. Okay, we're going to differentiate from both sides. What we're trying to do is we know that e raised to minus lambda is equal to 1. Probability of any function of sum 0 to infinity will always be equal to 1, right? So now we're trying to solve this whole equation by differentiating, by moving everything from one side to the other side. Okay, we are going to solve the since e raised to minus lambda is not dependent on the sigma function, we can easily move this on the other side, which I did over here. Okay, now we're going to differentiate with respect to lambda on both sides. Upon differentiation, we get to know that putting m is equal to over here and lambda raised to m minus 1 by m factorial is equal to e raised to lambda. Okay, so lambda raised to m minus 1 can also be written as lambda raised to m by adding a substitute at m over here. It can also be written like that. Okay, so now using the properties of integration, we get to know this, finally get this equation over here. Okay, now moving on, we get to know that is e of x, since we differentiated already from both the sides, is equal to sigma m is equal to 0 to infinity m into e raised to minus lambda into lambda raised to k by m factorial is equal to lambda. Basically I move this e raised to lambda back into this side of the equation, and then we finally get this, and then this is nothing but e of x. So now I found what is e of x. Next we need to find the value of e of r of t1 comma t2. So now since we already know the value of e of x, it's easy to find e of t comma t2. We substitute the values of t1 comma t2, and then we finally get is equal to e raised to lambda plus e raised to lambda. As simple as that. Thank you guys.